Hi, and welcome to this tutorial series on CH32 RISC-V microcontrollers. Now, a lot of us already know what's the difference between RISC-V and ARM microcontrollers. Both are 32-bit microcontrollers, but there are some differences. RISC-V is an open source platform, and it is much cheaper and also pretty young compared to ARM microcontrollers, which are powerful performance series microcontrollers. Many of us are already familiar with the STM32 series of microcontrollers and also other microcontrollers from Philips, and also Philips, now it's called NXP, and other platforms as well. And many of us are already also familiar with ESP32 and PIC32 microcontrollers, Atmel 32-bit microcontrollers as well. But the RISC-V microcontrollers are now grabbing the market by surprise due to their cheapness and reliability. Nowadays, we also have RISC-V series ESP32 microcontrollers as well in the form of ESP32C series. So the RISC-V microcontrollers are now the talking stock of embedded system world right now. And I will be particularly talking about the CH32V003F4U6, and all of my work is based on these tiny little microcontrollers. As you can see from their official website, it's a RISC-V microcontroller, and it has a maximum operating frequency of 48 megahertz, which is not that much compared to the hundreds of megahertz speed of STM32s and other microcontrollers, but still it's a decent 48 megahertz 48 megahertz speed. We also have very small in terms of space. The flash is very small, 16 kilobytes only, and also small quantity of RAM, that is only 2 kilobytes compared to what we are usually familiar with other 32-bit microcontrollers like STM32s. But sometimes small things pack a lot of punch, and we will see how. So let's see the datasheet of this microcontroller. Now I must say that the website for this CH32 microcontroller manufacturer, that is the Nanjing Qingheng Microelectronics, is a bit slow in my country. I don't know if it's a global issue or something else, but it's very difficult to navigate through their website. But still, it's quite if we can wait, we can still manage to get some data. And we also have Chinese and English documentation as well. So this is the page for CH32V003 series, and it's highlighting the basic features. So it's a Quinky 32-bit RISC-V 2A processor, and it has a maximum operating frequency of 48 megahertz and 2 kilobytes of RAM, 16 kilobytes of flash. It can operate with 3.3 and 5 volt, and this is one big difference, because most of the ARM microcontrollers, they cannot withstand voltages beyond 3.3 volt. Some pins of those microcontrollers may be tolerant to 5 volt, but not as a whole. So then there are other features like 10-bit ADC, op-amp, and then there is a DMA controller, and there are two timers, one 16-bit and one general purpose timer. We have 2 watchdogs, one UART, one I2C, and one SPI. And there are 18 GPIO pins with external interrupt support. In terms of features and coding, you will find it familiar with the STM32 series microcontrollers in many ways. So this is the website for the CH32V003. I'm not going to download the datasheet because I already have it. So if you want, you can have it downloaded for yourself. And the next thing I will be talking about is the development platform, or IDE. So basically, the MRO Studio or Mount River Studio is the IDE that we'll be using. It's an Eclipse based IDE. So let me show you how it looks. You will find it quite similar to other Eclipse IDEs, so there is not much rocket science in that. It's quite easy to use, and once we start looking at the codes, we will see that it's almost a replica of what we used to have with STM32Cube IDEs, and this is where it gets very interesting and very easy to code. So this is the Mount River Studio, and these are already the projects I have already completed and we will be discussing in the future. So let's create a blank project. So we start by clicking new, and then we go to a Mount River project, Mount River Studio project. So the first thing we will need to do is to declare the microcontroller that we will be using. So I will be using CH32V003F4U6. So this is now selected, and then I will give a project name. Let's say it's a test project, and optionally I can create a location for that project. So let's say this folder, and it's all done. Finish. So once the IDE has created the project folder, you see this is the project folder here. So it has a include folder, core, debug, startup, peripheral, etc., etc., and then the user, where we have the main C file. So this is the blank project. So now if we can see that it's quite similar to the coding we used to see with STM32 microcontrollers. It's quite similar, and I will show you in later videos how it's similar. Then another thing I have to say about WCH microcontrollers, they have RISC-V microcontrollers, they have Cortex microcontrollers, they have also 8051 series microcontrollers and other wireless communication based microcontrollers as well. And this makes their portfolio a bit heavy, but not as heavy as, let's say, STM32 or ESP32 series microcontrollers. So this will be the end of first part. See you in the next.